just a little bit about myself. So I'm Lucy Kennedy. Um, kind of two roles. I'm CEO and co-founder of Spottitt, which is a satellite analytics company specializing in monitoring services for clients within the infrastructure sector. I also have a second hat. I work with the European Association of Remote Sensing Companies, and I'm there. It's a funky title, EO Evangelist for Infrastructure. But what that means is I go and talk with the infrastructure sector, evangelize about what Earth observation and what satellites can do for them, but also listen to their needs and their issues and try and feed that back to the EO sector as well. So it's a kind of two-way conversation. And today we're going to go through some quite general myths, which would be relevant probably to whatever sector you are working in, and going down towards some more infrastructure specific myths and questions. These are all things that we've been asked more than once by clients and potential clients. So it's just, we hope we can kind of push you a little bit on your journey here and move you forward and help you understand whether satellites is something that you should be looking at for your business and business intelligence and monitoring of infrastructure. Let me try and change slides. So just very briefly, when it comes to infrastructure, this is a very brief overview of the kind of services that Spottitt provides for our infrastructure clients. I'm going to let you just have a quick flash look at that. Today is not about us talking about our services, but I do want you to have a little bit of a framework of the kind of things that we do. And this is derived from different types of satellite imagery and satellite data. We're experts in all different types. Also, I think that just a few of the logos of the clients that we've worked with. And the idea for that is we get to show off a little bit, but it's also we have people from all kinds of different infrastructure sectors. And maybe you can see a company on that list that is similar to yours. And these are all people that have done a paid work or are doing paid work with Spottitt and monitoring of their infrastructures. You'll see power, gas, water network operators. We also have renewable energy clients looking at site selection tools, and not on that slide, but we have a growing number of local authorities as well who are using our biodiversity watch for their natural capital and biodiversity baseline activities. So let's dive in with one of the first questions we get asked. People think it's going to be hugely expensive. Also, people are very aware that there's also some free satellite imagery. So what is the truth of the matter? And I think people are always surprised. I don't know if it's going to work. Does anyone want to make a guess at how much they think, high resolution, colorful satellite imagery is? Is anyone going to be brave enough on air? No, I know there's some people on the call that know the answers. Paul, I think you're with us here from Planet, which is the provider of high resolution optical imagery. Well, the truth is that you can, depending on the resolution and depending on the provider, you can buy, sub-meter resolution imagery ranges from about £6 to £25 per square kilometre, and that's the kind of imagery that people are familiar with using. It's often a starting place for that. But there is also a huge amount of free satellite imagery and data. So free data, there's a huge amount of data around climate conditions going back 15 to 20 years. There's also free and open source satellite imagery of different types. So in Europe here, we have the Copernicus program, and particularly the Sentinel constellation of satellites that's taking optical and SAR imagery every 5 to 12 days everywhere in the world at 10 meters resolution. And this is all completely free and open source. And, there are a lot of analytics providers that focus on just the free data. Others like Spottitt use both free and open source. I think the difference you need to understand between free imagery and commercial or paid imagery and data is that Generally, free imagery and data is at a lower resolution. So if you talk about free color image satellite imagery, its Sentinel-2 is at 10 meters resolution. If you're talking about commercial imagery, that goes down to sub-meter resolutions, all the way down to 30 centimeters in resolution. The other big difference between open source and commercial is with commercial, you can control when you want your image taken and of what. And with open source, generally that's the imagery and the data is captured on a fixed cycle. So every week, every 12 days, whatever it is, depending on the cycle. So, be aware that both exist, but satellite imagery is by no means as expensive as people often imagine. It's no longer the realm of just the military and governments. There are really companies that are using this and having great value out of this imagery and data. Um, Here's another one, another subtlety that it's good for people to understand and terminology. So, archive commercial imagery is cheaper than new imagery or tasked imagery. That's the phrase that's often used in the industry. So, archive commercial imagery or data is imagery or data that was captured for someone else potentially and has been put in the archive after a certain amount of time. So it's historical data, it's past data. So even, high resolution constellations, they've been around now for up to 12 years. So there's a huge archive of historical imagery. And for some applications, maybe you want to look in the past and you don't need to task or capture specifically data or imagery for your applications, but you can look at the existing archive. Now, depending on the provider or the constellation, an image can become archive and therefore cheaper, anything from 3 days after it was taken up to 3 months. It really depends on the provider. And generally, archive imagery and data is half the price, plus or minus, of the tasked imagery. But of course, you're limited to what somebody else captured. But if it meets your needs, that's perfect. But that's often a confusion that people have. What is archive? What is task? That's the difference. Archive is old imagery that sits there that can be used, can be purchased, and is cheaper. New imagery or tasked imagery and data is data that's captured specifically for the client over your infrastructure when and where you want it. Don't see any questions, so I'm just going to keep pressing on, but please do raise your hand when you have a question. This is another interesting one. You never actually own the commercial satellite imagery that you buy. True or false? Does anyone want to dare to make some comments on this? Fair enough. That's what I'm here for, is to give you the answer on this one. In practice, actually, you never own the satellite image or data. What you actually pay for is the license to use it. Um, so what's very important here when you work with satellite analytics providers or service providers that are deriving analyses and insights from satellite imagery is whether they are authorized resellers of that data, because only an authorized reseller can transfer the license of the satellite imagery or data that was purchased to you as the end user. And now what we find as Spottitt is that, our clients are charged for the satellite imagery and data that we purchase to generate the services and analytics that we deliver. And our clients want to be able to end up and to be able to use that and to have that imagery and data in their databases. Imagine you have several years worth of high resolution imagery of your assets. There are new insights, there are new projects, there are legal things that you can use that imagery for, and you want to be able to be the owners of the license and be able to use that. So that is an important subtlety. And definitely when you talk to different analytics providers, do explore that with them. Can they pass on the license to the original, the source imagery and data to you so that you own that as well as the output analytics? This is often a really complicated concept. It's a big frustration that we still like licenses here. I think it should move to a fair use license agreement, but maybe one day I'll get my way. Does anybody have any questions on that one? As we often get people looking a bit cross-eyed when we have to try and explain that, you've got the image, but you've actually got the license to use the image. Okay, good. So that is crystal clear. Let's roll on. Um, a lot of our clients have assets that are sensitive in nature or close to sensitive sites, airports, nuclear facilities, military facilities. And we often get asked, but we're not allowed to fly our drones or aeroplanes. You probably wouldn't be allowed to capture a satellite image over such a site. Well, that's not true. Satellites can take a picture anywhere in the world that their orbit allows them to take. There are no legal or other constraints over taking a picture of a military, nuclear, airport, or whatever sensitive installation. What there are some subtleties on is in terms of know your customer and embargo countries. So as an authorized reseller of satellite imagery and data and an analytics provider, if you were a company from North Korea asking to have a picture of Harwell Space Campus, where I sit now, I would not be allowed to sell you any imagery or analytics because the company comes from an embargo country. Conversely, if I work with a UK client here, I can take whatever pictures of North Korea they want. So that's a little bit the subtlety of where we can and can't provide imagery and analytics, but it's nothing to do with whether the satellite itself is allowed or not to take that picture. Um, the other subtlety you might have is, for example, if your imagery provider is a US company, the US might constrain them from exporting and or selling the license to imagery over sensitive sites. But again, it's not because the satellite can't take a picture of those sites. So that's one of the beautiful things. Probably that's why I love satellites. I'm perhaps a naturally nosy person. It gives me a great thrill that I can, as Spottitt, we can take imagery and run analytics for assets all over the world, and you cannot beat a satellite for scale of data capture. So those are a few words around the subtleties around, what imagery can be taken and where. It's easy. We can take it pretty much anywhere in the world. Ooh, can satellites see through clouds? We've got lots of lovely cloud cover here above the Harwell Space Campus at the moment. So, could satellite sensors see through that and provide me with relevant data for analytics? I'm going to show you two different types of pictures here and talk a little bit about that. Because the answer is some sensors can see through clouds and some sensors can't see through clouds. So on my right, I don't know if that comes out as your right or your left, but there is a colour picture that's somewhere in the UK, some river in the UK. That is an optical image. And we've probably all got quite used to seeing these images now after with the conflict in Ukraine. We've got used to seeing high resolution optical satellite imagery. This imagery cannot be taken at night. And if you took a picture with a cloud in the way, it's just like taking a picture from an aeroplane with the cloud in the way. You would see a big white puffy blob in the way and you would see the cloud shadow, and it would be impossible to do any analytics on that image. Conversely, on the left-hand side, the rather strange black and white looking image, that's from a radar sensor or a SAR sensor. It's a different type of sensor, and that imagery can be taken at night or through clouds. And it's particularly useful for applications like near real-time flood monitoring and sort of post-disaster change detection and a number of other tools. Um, so you need different software and different skills for doing analytics with different types of sensor data. And it's worth also mentioning you've got thermal data from space, you've got data for all kinds of different, weather and climate parameters coming from open source and commercial providers in space. And also increasingly, we have data on different types of greenhouse gas concentrations and other nasties in the atmosphere, both open source and from commercial providers. So each sensor have its own peculiarities, but the one that can see through clouds is the black and white SAR sensor on the left-hand side. But what you will understand is that from the point of view of a non-expert user, the color images are much easier for end clients to use and to validate the analytics that are generated from, because it's quite visually intuitive to go and look at your analytics and then go and look at the picture that it would derive from and say, yes, I can see what's going on here. It's less easy from a SAR sensor, but each sensor, has its own specific use cases and uses. And so you want to work with an analytics provider that understands the capabilities of all the different types of sensors in space. So there's the sort of some yes, some no answer in terms of can satellites see through cloud. Now, in terms of the issue of cloud, that's not really the end user's problem. So generally, if you request services that be managed by your service provider through their satellite imagery and data provider, and they will capture imagery on clear days through the clouds, etc., depending on your needs. That's not something as the client you need to worry about, and you don't need to pay for imagery with high levels of cloud cover. That's at the risk of the data provider, and that's managed at their end. Um, Here's an interesting one. We do talk to some people that seem to think that, the sort of images taken from, high resolution optical satellite imagery is a substitute for aerial imagery. And the answer is kind of yes and kind of no. It depends on the resolution of the aerial imagery that you are using. So nowadays, aerial imagery is typically 6 or 12 centimeters in resolution. But if you go back 5 to 12 years, people were using, 24, 50, or even 1 meter resolution aerial imagery. Now, on the optical side, so the pretty color images, that goes down to 30 centimeters resolution. That's the highest 25, 30 centimeters is the highest resolution commercial optical satellite imagery available today. So if you are used to using, 24, 50, 1 meter, then satellite imagery is indeed a kind of like for like substitute for aerial imagery. If you're using modern stuff that's going down to 6 centimeters or even flying drones and getting really 1 or 2 centimeters of resolution, then optical satellite imagery isn't an equivalent. So you like to think of aerial imagery can operate at centimeters of resolution, and satellites can operate at tens of centimeters of resolution. But in terms of the scale of capture capability, you cannot beat a satellite for the quantity of data that can be captured, the square kilometers of assets or the kilometers of assets that can be monitored in a short space of time. Any more questions on that resolution? We've got some other questions later on that link to that. Okay, all right. Um, So some of the clients we work with are quite advanced, they have GIS software, but perhaps others aren't. So, do you need in-house GIS software, remote sensing expertise to get value out of satellite data, satellite imagery, and analytics and services derived from that? I think the question is no, you don't. But you need to then validate that. What is your data and analytics provider delivering you? So if you're going direct to the satellite data, you will need some GS and remote sensing expertise in-house to be able to view and handle that and generate insights from that. If you go to an analytics or service provider like Spottitt, then we will generally have platforms, tools with which through which we share the satellite data and the analytics and services that we generate, and therefore it's not a requirement to have any GIS specific skills in-house. So again, decide what you need, talk to your data and analytics provider, and make sure that there's a good match between what they're going to do and the expertise they're going to provide and what you need and what you can offer in-house on your side. This is a great, 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 great question. And here we're kind of rolling into the area we're looking specifically probably at asset owners. So we get a lot of power network operators, gas network operators, oil and water pipeline owners who come and they say, I need to monitor my pipe. You need to make sure that it's 2 meters of clear, no vegetation either side of my pipeline. And then I have to say, how accurately do you know the location of your pipeline? Because if you only know the location of your assets plus or minus 10 meters, I can do my analysis plus or minus 2 meters, but maybe you've told me that it's in the wrong place. And this can be a big issue or a small issue. You will know yourselves how well located your assets are and how accurately, therefore, you can request a sort of monitoring provider to be. A lot of us can help with that too. So we have, for example, pylon detection algorithms. So we can help our clients if they don't know exactly where their pylons are, instead of going through and manually, spotting where they all are, use algorithms to determine where the pylons are and use that then as the accurate location of your assets. I've had some instances where we've been reviewing monitoring with a client who said, our gas pipeline is here, and we've been able to say, I'm pretty sure your gas pipeline isn't there, because we can see very clearly on the satellite imagery, the disruption with the poor yields for farmers' land. We can see that actually your pipeline is running 20 meters west of where you say it is. But that is a factor when you're looking at geospatial analytics in general, is you need to tell your provider where your assets are. Um, so another question that we often get: does using, sub-meter resolution commercial satellite imagery and data raise any GDPR issues? Um, well, the reality at the moment of that is that no, it doesn't. You can't see a person's face. You can't read the number of their house, the number plate of their car, because we're operating at tens of centimeters of resolution. So it poses no GDPR issues today. That doesn't mean it doesn't generate some uh, privacy issues or privacy sensitivities for some of our sort of infrastructure owners who are monitoring infrastructure that goes across other people's land. But in general, it's never been a big problem. I would say that there are new constellations of satellites being funded that would potentially go down to 10 or 12 centimeters of resolution. So in that instance, GDPR might become something that as an industry we would need to have guidelines and procedures over. But it's not something that, from the point of view of provider of data and analytics, that is generally an issue in the monitoring projects that we've worked on with infrastructure owners, be they overland assets, underground assets, or natural assets when we're monitoring landscapes as well. Right, so when I ask this question, I'm going to click onto the next slide as well and show you a picture. It's often something we get asked. Can I see your power lines in high resolution commercial optical imagery? And I'm going to show you this picture. And I'm going to ask again if anybody wants to be brave enough to say what they think they see in this picture and answer that question. Don't be shy. You're among friends. No, no one being brave. Well, a lot of people would, without thinking, say, yes, I can see the lines. Look, here's the pylon, here's the lines. I can see the power lines. That isn't actually the power lines or connectors, as they're called in the industry. It's not actually the pylon itself. That is the shadow. The pylon is here, going more vertically up out towards us out of the image, and that's a long, long shadow of the pylon and a shadow of the connectors. The connectors are running more here, the overhead lines, and you cannot see them in the satellite imagery. And I think when it's a good rule of thumb, when you're working with data, is you would never ever make a classification or a prediction from one pixel. So if this is a 50 centimeter resolution image, so each pixel of the satellite image is 50 centimeters by 50 centimeters of square on the Earth, you would always want to imagine that you would be able to start to see things when they become 4 joined pixel in size. So if you're using 50 centimeter resolution imagery, you wouldn't want to be promising to anybody that you could see anything or classify anything that was, less than a meter square in size. So we do get questions, can we see birds' nests on pylons? Can we see cracked connectors? And the answer is no, we cannot. That doesn't meet the criteria of the 4 pixel area. Likewise, if you're working at free and open source scales, so if you compare this to free and open source optical imagery, that's 10 meters in resolution. Each pixel is therefore 10 meters by 10 meters, so 100 square meters. If you're looking at the 4 pixel rule, you're looking at 400 square meters. So as you can see, as you go to lower resolutions, the size of the thing that you can spot gets proportionally a lot bigger. So at sub-meter resolutions, we can see things from 1 to 2 meters squared upwards. Free and open source scale, it's kind of 200 meters squared plus on that one. So I'm sorry, we can't see your power cables on that one. So that's a myth I want to bust straight away. Here is another interesting one. So one of the common uses of SAR imagery is to generate land or asset motion data. And you can use open source data for this, which is 5 meters by 15 meters in resolution. You can also use commercial data for this. But if we look at the open source, you need a whole stack of images. So this image is taken every 12 days, generally everywhere in the world. So you want to have a stack of about 20 images, and then you can create your baseline and start to calculate in millimeters per year how much that pixel of land or the asset on that land has moved. And people always struggle saying, yeah, but the imagery is 5 meters by 15. How can you be so accurate with the millimeters per year? And it's pretty tricky to explain. I'm going to take a very rough stab at it. But SAR sensors, they are active sensors, so they send out a radio wave and they are monitoring what comes back to them. So they're looking at things like backscatter, phase, coherence, all things that I can't explain, but my SAR expert could if we had Zara on the line. And from that, you can very accurately build up a picture of how much that point of land is moving, to the extent that you can calculate that in millimeters per year, because we're generally not moving a huge amount very, very fast. And what that means is that once you've built up your baseline with your stack, you can look back historically, on average in 2017, 2018, 2019, how much are certain points of land or assets moving per year. But you can also monitor ongoing. There's a new image that can be added to the stack every 12 days. And when you get that new image, you can also calculate then the relative motion of that data point versus the previous image that was taken. It's also important to say that this kind of analysis is most effective over man-made assets. So in urban areas, roads, railways, the SAR sensors respond particularly well, and you get a high density of data points. And one things that we've been exploring with, one of our clients is putting actually a SAR reflector. This is a kind of metal prism on their large transmission network pylons, that would then mean this signal, the response you see in your land motion or asset motion analysis, is definitively, you can match it to that asset and you can say that is the motion of that asset, as opposed to the motion of the land or any other assets around it. So there are some interesting things that can be done there around looking at the movement of land, or probably more important for many of our customers, they get excited when their assets start moving by more than a certain amount per year, or more than a certain amount between one image and the next image being taken 12 days later. But it can be done to millimeters per year accuracy, even using open source imagery. The difference is if you use commercial data, you need less images in your stack to get a good analysis, and you will also get a higher density of data points because the resolution of your images is better. Okay, all right, moving on. And I think this is my last question, which is right about on timing, is so satellites for methane monitoring, and I'm thinking particularly of people with, gas networks, gas installations, gas sites, fantasy or relevant monitoring technology. Now, this is a really exciting one. We probably should do a webinar just on this topic. So what is true today is that there are open source sensors in space that can, they're very sensitive, detecting methane, increases in the column of methane in the atmosphere by 2%. They can see that when it's more. And there's one commercial provider of methane monitoring, which is GHGSat, where they're at about 3 to 4 meters resolution. They can spot gas leaks that are generally about, depending on the conditions, 60 to 100 kilograms per hour. Now, and it's successfully being used in terms of monitoring gas production, gas usage sites, and gas extraction sites. In terms of whether it's fantasy or relevant monitoring technology, that's very much in the hands of the European Commission at the moment. So there is new legislation around methane monitoring and methane gas leakages, and it depends very much where the European Commission go in terms of the thresholds that they put in the legislation, whether gas network operators will be free to explore airborne, satellite-borne solutions, or whether they will be constrained by very low thresholds and pretty much have to go and walk the line and sniff the line. And the latest iteration from the EU was really talking about 17 grams per hour as being leaks that would need to be monitored, detected, reported and resolved. And that would basically limit gas network operators to pretty much handheld or other devices going along very, very close to the pipeline. So there is spaceborne technology for methane monitoring, methane as well as other greenhouse gases. There are new constellations coming online that will have lower resolution, increased sensitivity. Will we be monitoring our gas networks with satellites? Depends on the thresholds that are agreed within the EU. Maybe, maybe not. And I think that brings me to the end, at least of the ones that I put down as going through, and I hope people have other questions. I will try and answer them. If I can't, we'll get back to you later on. And you've also got my contact details there. You can also contact Spottitt via our contact us forms. We'd be happy to guide you if at all we can. So yeah, should we open the floor, Elena, see if we got any questions?
Yeah, sure. Actually, there are a couple of comments in the chat. If you
Okay.
can check, Lucy. And
Maybe you
then
read them out. Maybe you could read them out to me and then.
Okay, so the first question is, can satellites help planning areas for new electricity distribution lines?
And who was that question from? Maybe they would elaborate on their question.
A question from Nicolo.
Okay, all right. So certainly it can, because of course with the satellite we can look at what the land cover is, we can look at the height and health of the objects and vegetation on the land, we can look at the digital elevation of the site, we can also look historically at, is this a site that's prone to flooding, high soil moisture, land motion issues, so you can look at all the different aspects of satellite data and the different types of monitoring services that can be delivered, and you can use that to then determine, if you have a choice of routes, what might be the best route in terms of, quicker construction, more direct route, less geographical challenges, or the best route from the point of view of reliability of the future infrastructure that you're going to build there. Is it going to go through an area with high flooding, or do you put it on higher land where you've got less risks? But then do you have landslide or land motion risks? So the answer is yes.
Thank you. There are actually two more questions and one more person is typing. So the second question is, what is the typical accuracy of geographical coordinates XY of satellite imagery?
So that depends on the resolution of the imagery or the data that you are purchasing. If you're talking about high resolution commercial data, it ranges in accuracy of between 1 and 3 meters, depending on the provider and the data source. And certainly when we look at sort of utility network monitoring, when you are monitoring often meters of network, that's one of the factors we look at closely when determining which data provider to work with for those kinds of services.
Next question is, can you elaborate a bit more on the software solution that Spottitt provides?
Oh, am I allowed to do a bit of marketing in this general call? So I will go quickly back to the services, and I'll just expand a little bit on that one. So Spottitt develops services, monitoring solutions derived from commercial, open source, and in some cases hybrid, optical, SAR, climate and greenhouse gas satellite sensor data, and we do combine it with other remotely sensed data, for example, lightning data, when appropriate. What's important about Spottit's solution is, of course, yes, behind it is pretty satellite imagery and, classification of land cover, single image height analysis of objects, etc., etc. But we deliver it to our clients in our web-based Spottitt Metrics Factory delivery system. And what that means is that our analytics are mapped to our clients' assets. So we put into our system your assets, and the incidents or issues are mapped to your assets, and you can view those purely then as numbers and metrics. So what percentage of a particular overhead line corridor is encroached by vegetation, what's the estimated volume of that vegetation per section, etc., etc. And that data can then be pulled via API into our end client's existing GIS, asset management, or even work order management systems. So we're not aiming to provide, a complex, heavy platform to replace any of our clients' platforms. What we're looking to do is enable our clients to integrate geospatial data derived from satellite imagery into their existing platforms and asset monitoring and asset management tools. So please ask a follow-up question if I didn't cover enough, but don't want to talk too much and be too specific about Spottitt. But thank you for the question.
Thank you, Lucy. Another question in the chat: how accurate can vegetation height be determined?
That's a really nice question. So let's leave on that screen. So when we're talking about vegetation height, I guess, a number of people on the call will be familiar with using LiDAR, which is very expensive, extremely accurate. You get a 3D model of the vegetation and objects in and around your assets. Spottitt can approach the problem of height in two ways. You can take multiple, or what's called stereo satellite imagery, and from that you can generate digital elevation data. That's quite expensive, and generally it has the same accuracy of the satellite imagery that you're using at best. So if you are using a 50 centimeter resolution satellite imagery to derive that, it's going to be at best 0.5 meter to 1 meter in accuracy in terms of the height measurement on that. What we're finding that's really interesting for a lot of our clients is a single image height estimation. And I stress the fact that it's an estimation. So it's an algorithm-based estimation of the height of the objects in and around a client's asset. And we're not going to give you an answer 1.379 meters. It puts the height of the object into buckets: 0 to 2, 2 to 4, 4 to 6, 6 to 8. And it's derived from the same imagery that we are using to do vegetation, encroachment, third-party change and risk detection. So it's a kind of quasi for free add-on, and it gives our clients a look-see as to where they will start to have height issues, but from the point of view of it being an estimation. So you've got a couple of options there when it comes to height.
Thank you. And actually, I've got 3 more questions from people who couldn't make the time. So the first question is, thank you. How do seasonality and weather conditions impact image capture capacity?
Okay, again, a good question. Depends on what sensor you're using. So if your solution is near real-time flood monitoring, or if we're doing SAR-based change detection or land motion monitoring, the answer is doesn't matter. We can do it at night, we can do it rainy season, sunny season, it really doesn't matter. When it comes to services like vegetation management, when we're generally using optical imagery, there what you will find is we will make less stringent commitments on the frequency that new imagery can be captured, and it's very it depends a little bit on the geography. So the further north you go, you know, the more challenging that can be, also because the days get shorter. And other parts of the world, it's really a non-discussion, even in the winter or summer months. That's always something that's best asked to your data and analytics provider. They will work with the data providers to give you a fair and honest estimate. In terms of capacity up in space, that's really not the constraining point, and there's increasing capacity. So ultimately we'll reach a point where winter and summer doesn't really make too much of a difference, because the satellites, there's always ultimately a clear day or patches of clear areas, and satellites will be able to, will have new edge computing technology and things on board them, which will enable them to take more pictures between the clouds in the cloud-free areas. But it is something to consider. But you have to keep in mind, a lot of our clients are monitoring their asset on a sort of once a year, once a 2-year, once a 3-year basis. Some go down to monitoring every 2 weeks. And so, you know, increasing the frequency of that monitoring cycle using satellites is a no-brainer at all. And winter and summer doesn't really cause a big challenge in that. Gas network operators tend to monitor more frequently, even down to every 2 weeks. And there we can offer combined solutions whereby if optical data can't be captured in time, then SAR imagery and SAR change detection can be done to flag risks and changes in and around the network, independent of cloud cover.
Okay, thank you. Another question is, can you create a multi-dimensional representation of the object with a satellite image, like 3D or 4D?
So what does exist is you can create sort of 3D mesh images, where it's a combination. You take multiple satellite images, you generate digital elevation for that, and then you mesh that image over your digital elevation. So that does mean you can fly around, you know, skyscrapers, and you can see the data from a sort of 3D, 4D point of view. It is possible.
Clear. And the last question is it correct that the most extensive and reliable imagery capture is only provided by a supplier with the largest constellation of satellites?
Oh, now we're entering into very, very complex area. So in simple terms, the more satellites a data provider has, the more frequently they will pass over the same spot on Earth in a 24-hour period. And therefore, logically, you know, they can capture data over that area more frequently. That is not always the case, and the reason for that is that satellites are solar powered. They have to receive from ground stations on Earth their commands, and they also have to downlink the data that they've captured. And then different satellites, different providers have different constraints on how much data they can store, how many images they can capture and store on the satellite before they need to downlink it and capture more imagery. Satellites are also solar powered instruments, and depending on the sensors, some sensors take more energy than others. And if you have a constellation of very small satellites, they won't be able to take so many pictures before they in essence go into recharging mode, and basically can't take pictures but are recharging, and then only when they're recharged can they then take another picture. So yeah, beware of, you know, it's not always true that someone says that I'm going to pass over 20 times the point on Earth and be able to take a picture 20 times. That's not the reality, that they would actually be able to take a picture 20 times in a 24-hour period, because a chunk of those satellites will be in recharging mode, or will be full, or they'll be repositioning to take a picture from something that an image that they've just taken. So what I would look at is number and size of satellite. Big satellites have big solar panels and big storage and less constraints on that side. So it's a combination of those two.
Clear. No more questions, Lucy. Thank you very much.
Thank you, everybody. It's been a pleasure.